Hello and welcome. This lecture deals with quadratic functions applications that are including maximum height. And this lecture is about completing the square. And later on in this lecture, we're going to look at using the formula to find maximums of a projectile. So the outcome is, given a quadratic function representing the path of a projectile, the student will use completing the square to find the maximum height that it will reach. So it's the maximum height, the time it takes to reach a maximum height, and the time it takes to hit the ground. So let's take this example. An arrow is launched at 96 feet per second from a building that is 112 feet high. The function that represents the height of the object after t seconds is h of t equals negative 16t squared plus 96t plus 112. And you can realize this is a quadratic function. H represents the height, h of t, the height after t seconds. So t is the time in seconds, and h is the height. And if you look at this, being familiar with quadratic functions, the leading coefficient is negative, so this should be a parabola that opens downward. And if it opens downward, then it has a maximum. So we're going to answer three questions. What is the maximum height, as we said before? And then how long it takes to reach a maximum height? And then when will it hit the ground? So let's look at a diagram representing this problem. So if the object was, or the arrow was launched from a building that is 112 feet high. Say this is the building, it was launched. And so when it's launched up into the air, it's going to go up, reach a maximum, and then it's going to go down until it hits the ground. And so you can tell that this is the function is a quadratic function. It's a parabola. A maximum is the vertex. And so the vertex has coordinates t for time. That's your x-axis is the time. Your y-axis is the height. And so the vertex being a maximum would be the time. T is your the x-coordinates of the vertex, and h is the y-coordinates of the vertex. So once you find the coordinates of the vertex right here, then you answer the first two questions, which is what's the maximum height, that is h, and how long it takes to reach a maximum height. So basically, to answer the first two questions, you need to find the coordinates of the vertex. And as I mentioned right here. So let's look at how we do that by completing the square. So basically, we're going to find the coordinates of the vertex by completing the square. We start with this, the original quadratic function. And to complete the square, what we do is basically first isolate the first two terms, and then factor out the leading coefficient from the first two terms, only the leading coefficient. So when you factor 16 out, you have t squared. And notice you factored negative 16 out, so you're going to change the sign to negative 6t, such that when you distribute, you get back the original expression, and then leave the 112, the constant, on the outside. Now we have the negative 16. We need to complete the square, negative 16 times t squared minus 6t. Now to complete the square, to write it in the vertex form, so f of x equals a times x minus h quantity squared plus k. And so once you write it in this form, you can find the coordinates of the vertex. So to write in this form, we complete the square. So divide the take half of the leading coefficient, half of the linear coefficient, and I'm going to ignore the sign because I'm going to take half of it and square it. So half of 6 is 6 divided by 2, and which is 3. You square it, you get 9. So you're going to add 9 to make this a perfect square. Now, you've added 9 to only one side of the function, so you have to take care of it because you can't really change the original function. So to undo adding the 9, notice that 9, what you've added inside parentheses is 9 is not actually what's added to this side. What's added to this side is negative 16 times 9, because when you distribute negative 16 over this trinomial, the extra term that you've added would be negative 16 times 9, which is actually 144. So negative 16 times 9 is negative 144. To undo that, you're going to add plus 144 to make that go away. Make sure that the signs are different. This sign was a plus, then you've added a positive number, then you take it away. So you subtract rather than add. So whatever you do, you have to take it away so you don't affect this side. Then h of t equals, oh, that should be negative 16, sorry. Negative 16 times t minus 3 quantity squared. 112 plus 144 is 256. And so the coordinates of the vertex, as you know, is t minus 3. What makes this quantity 0 is actually the t that makes the quantity 0. What makes this 0 is a 3. So the 3 is the time. And 256 is your y. So if this quantity is 0, then you have 256 left, and that would be the height. So we found 256, where 3 is the time it takes to reach a maximum. Let's look at the graph here. So here, 3 is the time, as you see. There's 3. And then 256 is the height. And so we've answered both questions. So it takes 3 seconds to reach a maximum. And the maximum height is 256 feet. So that's basically question number 1, and that's question number 2 that we answered by just finding the coordinates of the vertex. The next thing that we need to do is to find how long it takes to, how many seconds it takes to hit the ground. So when will it hit the ground? So we're going to take this function. When it hits the ground, just like the graph you just saw, when it hits the ground, then the height will be 0. So you're going to take this function and set the height to be 0. And so you get 0 equals negative 16t squared plus 96t plus 112. And this is a quadratic equation that you need to solve. Well, I'm going to try to solve it by factoring first. Pulled negative 16 out, ended up with t squared minus 6t minus 7, which this turns out to be factorable. So when I factor it, I end up with the solutions from t minus 7 times t plus 1 times negative 16 equals 0. T minus 7 could be 0. T plus 1 could be 0. That's going to give you t equals 7 or t equals 1. But you're going to see that 7 makes sense. Now t equals negative 1 is not going to make sense as far as the time being negative. So if we look at the graph here, it shows that when it hits the ground, actually I graphed this function on the graphing calculator, and it showed me 7 and 0. And the negative 1 is right here. It's another x-intercept for the parabola, but it doesn't really make sense for this application. So the answer is it will hit the ground after 7 seconds. So in the next slide, I'm going to show you if sometimes those application problems, completing the square is not really convenient for real-life data. I know that your instructor would probably ask you to use completing the square, so you need to really know both of them, how to do both of them, how to use completing the square, or how to use the formula. Now, to find the coordinates of the vertex, the formula to find the x-coordinate of the vertex, so is negative b over 2a. That's the x-coordinate of the vertex. Okay, and so as you know, h of t is in the form f of x equals ax squared plus bx plus c in the standard form. And so your b is 96. So if you take negative b, which is negative 96 over 2a, 2 times negative 16, and that's negative 96 over negative 32, and that gives you 3. Notice that 3 is the x-coordinate of the vertex. So after 3 seconds, it will reach a maximum. So it's v of 3 and what? And I know there is a formula also that you have to memorize to find the y-coordinate of the vertex, but I really find the less you memorize is the better, because it doesn't, all what it takes is that you plug in the time, t, in the original formula, the original function, and find the height after 3 seconds. So t is 3 seconds when it reaches a maximum. So you're going to plug in t as being 3, negative 16 times 3 squared plus 96 times 3 plus 112 from the original function. 3 squared is 9. 96 times 3 is 288 plus 112. And no surprise, that's going to give you 256 as being the coordinates of the vertex, which answers the first 2 questions that we did by completing the square. So hopefully that makes some sense and help you understand this kind of applications. See you next time.